Hello, assalamu alaikum, dear students. So today's question is electrostatic field due to an electric dipole. ठीक है ना बेटा, very important question again. This is our question number 2 among the important questions. ठीक है ना बेटा, and it's really important for the board exams. Hi. And the question is like this: we have to calculate the electric field due to a dipole at a point in the equatorial line. ठीक है ना बेटा? Okay. And next is that at a point of the axial line. Okay. So first of all, this at a point of the equatorial. This is a dipole, simply a system of equal and opposite point charges, minus q plus q, it's a dipole. Fine. This is the center of dipole. This a plus a is equal to twice a is called as the length of dipole. Then here we define a physical quantity. So let me write it down here. That is p. That is p, which is equal to like this. It is equal to q multiplied by twice a. This is called dipole moment. What is this called as? Dipole moment. Charge multiplied by length of dipole. It's called as dipole moment. इसे हम क्या बोलते हैं बेटा? डाइपोल मोमेंट. ठीक. एंड इट्स ऑलवेज डायरेक्ट फ्रॉम माइनस टू प्लस टू. सो दिस इज द डायरेक्शन ऑफ द डाइपोल मोमेंट लाइक दिस इन दिस डायरेक्शन, डायरेक्टेड फ्रॉम माइनस टू टू प्लस टू. ठीक है ना बेटा? ओके. नाउ एग्जैक्टली व्हाट इज द क्वेश्चन? द क्वेश्चन इज दैट वी हैव टू कैलकुलेट इलेक्ट्रिक फील्ड ड्यू टू द डाइपोल. सो हाउ टू डू इट? What I will do is this: I will calculate the electrostatic field at the point P because of this plus q using Coulomb's law. I will calculate electrostatic field at point P because of minus q using Coulomb's law. ठीक है ना बेटा? Then take the vector sum of the fields to get the net electrostatic field at the point P. That's the procedure. Fine. Now, in order to calculate electrostatic field at point P, because of plus q and minus q, I will draw here this line and complete this triangle here, and then this triangle as well. Fine. Then we know that electric field due to positive charge is away from the charge. Electric field due to negative charge is towards the charge. So field because of this will be in this direction, exactly in this direction. So this is the electrostatic field which is E. And field because of this will be like this in this direction. So that's equal to E. ठीक है ना बेटा? Okay. Great. Perfect. Next I will assume that suppose this angle is equal to theta. अगर ये theta होगा तो ये वाला angle भी क्या होगा बेटा? Theta. Simply because this triangle and this triangle are simply congruent. तो ये थीटा और ये भी थीटा. ठीक है ना बेटा? नेक्स्ट इज दैट आई वांट टू कैलकुलेट इलेक्ट्रोस्टैटिक फील्ड. सो आई विल मेक ए कोऑर्डिनेट सिस्टम. यहां मैं एक कोऑर्डिनेट सिस्टम बनाने जा रहा हूं बेटा. ठीक है ना बेटा? तो ये थीटा है, तो इसका मतलब ये भी थीटा होगा और ये वाला एंगल भी थीटा ही होगा. ठीक है ना बेटा? बिकॉज़ ऑल्टरनेट एंड दीस टू आर कॉरेस्पॉन्डिंग. द नेक्स्ट व्हाट आई विल डू इज दिस: आई विल रिजॉल्व दिस E इन द रेक्टेंगुलर, ईच ऑफ द इलेक्ट्रिक फील्ड इन द रेक्टेंगुलर. देन आई नो दैट जहां से थीटा वहां cos और जहां नहीं थीटा वहां sin. तो यहाँ थीटा, तो इसका मतलब यहाँ से आएगा बेटा इसका कंपोनेंट e cos थीटा. e cos थीटा. ठीक है ना बेटा? और इसका एक कंपोनेंट यहाँ आएगा दैट विल बी इक्वल टू e sin थीटा. सो आई एम गोइंग टू रिजॉल्व दिस इन डायरेक्ट एंगुलर कंपोनेंट. सो द कंपोनेंट इन दिस डायरेक्शन विल बी e cos थीटा, कंपोनेंट इन दिस डायरेक्शन विल बी e sin थीटा. देन द कंपोनेंट ऑफ दिस along this will be e cos थीटा. So that e cos and e cos theta are the same direction, they will add. तो यहाँ से आएगा बेटा twice e cos theta. e cos theta plus e cos theta, that's equal to twice e cos theta. Then component of E in this direction will be equal to E sin theta. Now concentrate. अब यहाँ ध्यान रखो बेटा, जो E sin theta और E sin theta है ना बेटा, they are equal and opposite, so they will cancel. This E cos and E cos will add, so they will be twice E cos. And this is the net electrostatic field on the equatorial line. I will write like this E. Where E stands for the equatorial line. ठीक है ना बेटा? So that's what I am going to write down here. I'll write down like this: electrostatic field on the equatorial line at a point P is equal to 2 multiplied by E multiplied by cos theta. All right, 2 multiplied by E multiplied by cos theta. ठीक है ना बेटा? Why? You know that the E is the electric field due to the one point charge. So let me calculate the value of E separately, and let's calculate the value of cos separately, and then I will substitute it here. ठीक है ना बेटा? So E, अब E क्या होगा बेटा? You know that electric field due to the point charge क्या है बेटा? KQ divided by R square. KQ divided by distance square. So it will be equal to K multiplied by charge, that's equal to q, while here the charge is minus q or here this charge is plus q, divided by distance square. अब देखो बेटा, ये distance है ना और ये distance, that is exactly same. These 2 point charges are equidistant from this point P. So that means this length and this length are exactly same, but how much? That will be equal to under root of, this is R, this is A, so R square plus A square. Simply I will find for charge. This here perpendicular square divided by base square का root, that's equal to hypotenuse, isn't it? So it will be like this: it is equal to under root of R square plus A square whole square. ठीक है ना? So we are done with the electrostatic field. That's this. ठीक? Square and root will cancel, so it will be in turn equal to KQ divided by r square plus a square, exactly like this. Clear? Okay, next what I will do is this. I will try to calculate the value of cos theta. So let me calculate the value of cos theta. बोलो बेटा ये cos theta किसके बराबर होता है? It's equal to base divided by hypotenuse. Now this is a right angle triangle here. This is a right angle triangle. Suppose this is point A, this is point B. This triangle POA is a right angle triangle. While in the base is A and the hypotenuse is under root of r square plus a square. So I will write it down. It's equal to base divided by hypotenuse, that is equal to under root of r square plus a square. All right. Now it's like this. यहाँ ध्यान रखना बेटा, a divided by r square plus a square raised to the power 1 by 2. I'm sure you are following me. यहाँ ध्यान रखना. Next, simply I am going to substitute the value of E and the cost in this equation to get the net field at the point P. ठीक है ना बेटा? So that's what I am going to do. So I write it like this: electrostatic field at the point E, at the point P or on the equatorial line will be equal to 2 multiplied by all this, that's equal to K U divided by R square plus A square. ठीक है ना बेटा? Multiplied by cost के बदले में क्या लिखना बेटा? A divided by r square plus a square raised to the power 1 by 2, isn't it? ठीक है ना बेटा? अब यहाँ देख लो बेटा, here r square plus a square raised to the power 1, I can write here it's raised to power 1. Then here it's r square plus a square raised to power 1 by 2. Bases are same, power should be added. 1 plus 1 by 2 किसके बराबर होता है? 3 by 2 के बराबर. So I will write like this: electrostatic field on the equatorial line, K multiplied by Q into twice E. You can have this 2 and this E. Here this twice divided by r square plus a square raised to the power 3 divided by 2. All right. So this is the electrostatic field on the equatorial line. ठीक ना बेटा? Let me write it here. अब यहाँ ध्यान रखो बेटा. What I will do next is this. You know that the dipole moment is this. Q multiplied by twice. I substitute the value of this dipole moment here. तो ये electrostatic field क्या बनेगा बेटा? So what this electrostatic field will be? यहाँ मैं लिखूँगा बेटा. So let me write it here. Electrostatic field on the equatorial line will be equal to K multiplied by P. Is it? Isn't it? K multiplied by P divided by r square plus a square raised to the power 3 by 2. So this actually what the electrostatic field on the equatorial line. You can have this is the electrostatic field on the equatorial. Great, perfect. यहाँ मैं और एक चीज लिखूंगा बेटा. I will write down this electrostatic field in the vector form. The reason is it's a vector, obviously. लेकिन उसके लिए पहले आपको समझना पड़ेगा बेटा, the dipole moment here, this is the dipole moment, sorry, this is the dipole moment, it is B. You see it is directed towards right. Electrostatic field that is directed towards left, that means they are antipath. They are antipath. The angle between the electrostatic field and the dipole moment is 180 degree. So that's what I will write here. I will write down here in the vector form. I will write down this in the vector form. ठीक है ना बेटा? So here I am going to write down in vector form this electrostatic field on the equatorial line is equal to minus times K multiplied by P, all right, divided by r square plus a square raised to the power 3 by 2. Fine. So this is the electrostatic field on the equatorial in the vector form. By negative sign implies that the electric field and the dipole moment are antiparallel. They are opposed to each other. Fine. And at the end I will write down special case. And the special case is called a short dipole approximation. Short dipole approximation. So here I will write down this. Short dipole approximation. Short dipole approximation. Okay, short dipole approximation implies that the dipole is very short. And what does that mean? That means the length of the dipole is very small compared to the distance while you want to calculate the electrostatic field. That means this A is very small compared to R. When A is very small compared to R, obviously what you can write is this: R square plus A square is approximately equal to R square. It's approximately equal to R square. So electrostatic field, I will write down like this: electrostatic field on the equatorial line is equal to Kp divided by denominator में क्या आएगा बेटा? It will be equal to R square is what 3 by 2, 2 and 2 will cancel, so R cube. So this is the electrostatic field with the dipole on the equatorial line, but you short that. Fine. And you see that the electrostatic field with the dipole is proportional to 1 by R cube. It's proportional to 1 by R cube. ठीक है ना बेटा? Okay, so this is all we have in this. That's the electrostatic field on the equatorial line. Let me revise it quickly. Okay, so first of all we have dipole here. minus q at A point and plus q at point B, and this system of two equal and opposite charge, hence a dipole. The dipole moment here is q multiplied by twice A, alright, by twice the length of the dipole. Now we are interested in calculating the electrostatic field. कहाँ पर हमें electrostatic field निकालना है बेटा? At the point P, and that point P is on the equatorial line. This line is called equatorial line, and this line is called axial line of the dipole. ठीक है ना बेटा? We have to calculate some by here at this weak point. Okay, so the procedure is like simply like this. I will calculate electrostatic field because of minus q, because of plus q, then take the vector sum. ठीक है ना बेटा? That's what I have actually done. The electrostatic field because of minus q is towards q minus q. Electrostatic field because of plus q is away from plus q. ठीक? Now this E and E. So this angle is theta. I have assumed that this angle is theta. तो ये angle क्या होगा बेटा? थीटा. अब ये भी थीटा होगा और ये भी थीटा होगा. तो इन दो को रिजॉल्व कर लो, तो यहाँ से आएगा e cos θ और इसका कंपोनेंट यहाँ से आएगा e cos θ. So they will add and that will be twice e cos θ. E sin theta इस दिशा में e sin theta, this and this will cancel, hence the net field is simply equal to twice e cos theta. So that's what I have written here. Electrostatic field on the equatorial line is equal to twice e cos. Then separately using the Coulomb's law, I calculate electrostatic field because of one point. तो distance यहाँ से यहाँ बेटा under root of r square plus a square, तो उसका square root will cancel. So this 10th class geometry cos θ is base squared by hypotenuse. तो ये ऐसे लिखेंगे हम. So electrostatic field, then substitute this equation and this equation in the main equation. So 2 multiplied by यहाँ ये substitute कर लो और cos θ के बाद ये substitute कर लो. Base are same, power added 3/2 यहाँ आएगा. Q multiplied by twice a is p, तो यहाँ p insert कर लो बेटा. In vector form, since p and e they are antiparallel, तो यहाँ negative sign आएगा. इस negative sign का मतलब है बेटा this and this they are antiparallel. If this is towards right, this is towards left, and vice versa. ठीक है ना बेटा? Then short dipole approximation is this: if a is very small compared to, or then this electrostatic field implies electrostatic field to dipole is proportional to 1 divided by r cube. ठीक है ना बेटा? अब जो next इसके बाद है बेटा, you just pause the screen and write it down. जो next है बेटा इसके बाद, so what that's point number B. That's like this at a point on the axial line. That's like this at a point on the axial line. At a point on the axial line. So this our dipole again. So this here minus q plus q at A and B is dipole length obviously twice A. ठीक है ना बेटा? And then we know that what's the value of this p? This p is equal to q multiplied by twice A, isn't it? ठीक है ना बेटा? Moreover it is in this direction. So it is in this like this it is. I'll show it here. This here p vector direct from minus q to plus q. ठीक है ना बेटा? Again we have to calculate the electrostatic field at the point P. Okay, so let's calculate it. Okay. Now what is the procedure? Again the same procedure. First of all, I will calculate the electrostatic field because of plus q at the point P. Then I will calculate the electrostatic field because of minus q at the point P. Fine, and then take the vector sum. Okay. Now what I will write down is this. यहाँ आप अच्छी तरह से ध्यान रखना बेटा. Electrostatic field because of plus q will be in this direction, that will be away. And then I will write down here E1. And what is this E1? E1 is the electric field because of plus q, and it is directed towards right because it is repulsive field. The electric field because of minus q will be directed towards charge, तो यहाँ ऐसे होगा बेटा. ठीक है ना बेटा? So this is E2. More और जो E1 है ना बेटा, उसका magnitude ज़्यादा होगा compared to E2. The reason is that this distance which is BP is less compared to this distance which is equal to AP. Okay? So let's calculate it. अब यहाँ ध्यान रखेंगे बेटा. So concentrate here. What I will write down is this. I will write down first of all electric field due to plus q. Electric field due to plus q is that's E1. क्या है बेटा वो? That's E1. And how much is that? That's equal to K multiplied by charge which is Q divided by the distance. What is the distance between this and this? That's equal to this BP square. ठीक है ना बेटा? And let me write down here what's this BP. This BP, if it's clear to you, from here to here the distance A, और यहाँ से यहाँ तक है बेटा R. So BP is obviously equal to R minus A. And moreover, what about this AP? What about this AP? यहाँ ध्यान रखना बेटा. This OP is equal to R. यहाँ से यहाँ तक है बेटा R, और यहाँ से यहाँ तक A, so it is obviously equal to R plus A. So here I will write down R plus A. Fine. Then here I will substitute it. Now what I will write down is this is simply equal to KQ divided by BP is equal to R minus A whole square. Correct? Next I will calculate what? Electrostatic field. Electric field due to what? Due to minus Q. ठीक है ना बेटा? Due to minus Q is, that is E2. What is that? That is E2, which is equal to KQ divided by distance square, और distance क्या है बेटा? AP whole square. AP whole square, and that's in turn equal to KQ divided by R plus A whole square. ठीक है ना बेटा। नाउ इट्स ऑब्वियस इसका डिनोमिनेटर छोटा तो मतलब इसका E1 इज ग्रेटर कंपेयर्ड टू E2, ठीक है ना बेटा। नाउ यू सी दैट E1 and E2 they are opposed to each other but not same, they are simply opposite. So the net field at the point P that will be in this direction and I will write that is equal to EA, where A implies axial at a point the axial line. E1 is greater than E2, so EA I will write like this, ठीक है बेटा। So EA is the net electric field at the axial point, that is obviously equal to E1 minus E2, ठीक है ना बेटा, E1 minus E2. Now you see among the E1 and E2 this KQ is common, so I can write it like this, K multiplied by Q multiplied by K multiplied by Q and then multiplied by, and then what we are left with is this 1 divided by R minus A whole square, ठीक है ना बेटा, माइनस यहाँ मैं क्या लिखूंगा बेटा, यहाँ आएगा बेटा 1 divided by R plus A whole square, fine, ठीक है ना बेटा। Okay, next obviously I will go for the cross multiplication, so that's what I will write down here. So this here KQ multiplied by, यहाँ मैं cross multiplication करूँगा बेटा, R plus A whole square minus R minus A whole square, isn't it, divided by the product of these two. So here I will write down that is here R plus A into R minus A whole square, ठीक है ना बेटा, this here R minus A whole square, R plus A whole square. So here I will write down R plus A into R minus A whole square. All right. Now next, so here I am. यहाँ ध्यान रखो बेटा. So concentrate. Next takes like this. Okay, now open this term. So you know that A plus B whole square is equal to A square plus B square plus 2AB. That's what I will write down here. Electrostatic field on the axial line is equal. Here I will write down this KQ multiplied by this here A plus B whole square, which is equal to R square plus A square plus twice R. ठीक है ना बेटा, then A minus B whole square is equal to A square plus B square minus 2A. So I will write like this, minus R square plus A square minus 2 times R into A divided by this here A plus B into A minus B, that's obviously equal to A square minus B square. तो नीचे क्या आएगा बेटा, R square minus A square and whole square like this, ठीक है ना बेटा, so like this, right? Now what we cancel is this R square will cancel with R square, A square will cancel with A square, this twice RA, this will become positive, so it will add. So simply in the numerator there will be 2RA plus 2RA is equal to 4 times RA. Fine. In the denominator there will be R square minus A square whole square. So this is the electrostatic field on the axial line. Clear to you? Now let me modify it a bit. यहाँ मैं थोड़ा modify करूँगा so that I can substitute the value P here. So that's what I will write down here is this. Here first of all let me write down here it is 2K, it is 2 multiplied by K, right? Then I will write down Q multiplied by twice A so that I can insert the dipole moment here. 2K Q multiplied by twice A, तो फिर बचता है बेटा ये R, so here is R divided by R square minus A square whole square, ठीक है ना बेटा? Okay, all right. Then final equation is this: E at axial point is equal to this Q multiplied by twice is dipole moment. So what I will write down is this 2K P multiplied by R divided by R square minus A square whole square. So this is the electrostatic field on the axial line. This is the electrostatic field on the axial line. ठीक है ना बेटा? So again let me repeat quickly. यहाँ ध्यान रखेंगे बेटा, this is dipole here minus Q plus Q. Center of dipole length is twice A, so dipole moment is Q into twice A. Right? Now we have to calculate electrostatic field at point P, wherein the distance from the point P and the center of the dipole is given, that's equal to R. ठीक? So procedure is this: simply calculate electrostatic field because of plus Q, then calculate electrostatic field because of minus Q, then take the vector sum. That is the procedure. ठीक है ना बेटा? So dipole moment is in this direction, which is equal to P, that is into and equal to Q multiplied by twice A. तो पहले हमने यहाँ calculate करके रखा है बेटा, this BP is equal to R minus A and AP is equal to R plus A. ठीक? So electric field E1 will be this, distance is BP square, R minus A whole square, electric field due to minus Q, distance AP whole square, R plus A whole square, ठीक है ना बेटा? Then electric field will be equal to E1 minus E2. Why E1 minus E2? Because they are opposite, not equal but opposite in direction. E1 minus, तो यहाँ substitute कर लो. Then cross multiplication and a couple of identities. A plus B whole square is A square plus B square plus 2AB. A minus B whole square is A square plus B square minus 2AB. Denominator में आएगा A plus B into A minus B, that's called A square minus B square. So here I have used the identities. Then r square is going to cancel with this r square, a square is going to cancel with this a square, this twice ra, since this will become positive, so it will be equal to twice ra, so it is 4ra. Then try to insert the value of here what dipole moment, तो यहाँ मैंने लिखा था k into 2a, so twice k multiplied p into r square minus a square whole square. This is the electrostatic field on the axial line. ठीक है ना बेटा? Now next what I will write down is in the vector form and for the short dipole, and then we are done with the electrostatic field on the axial line. तो यहाँ आप ध्यान रखेंगे बेटा, concentrate for some time. यहाँ ध्यान रखो बेटा. Okay, so here it is. Now next what it is, next is this. So here I will write down in the vector form. In vector form, ठीक है ना बेटा? In vector form, you see that the electric field, net electric field is towards right, dipole moment towards right, hence they are parallel to each other. Hence the net electrostatic field on the axial line is equal to, what is that equal to? 2 multiplied by k into p vector multiplied by r divided by r square minus a square whole square. ठीक है ना बेटा? This one simply I replace this p by p vector. Clear? Then here I will write down. Next point is this short dipole approximation. Short dipole approximation. Short dipole approximation. What does that mean? That again means that the length of the dipole is very very small compared to the r. Okay, so here I will write down that a is very very small compared to, which in turn means that this r square minus a square is approximately equal to r square. Isn't it? R square minus a square approximately equal to r square. Then the electrostatic field will become like this. यहाँ आप ध्यान रखेंगे बेटा, electrostatic field will be simply like this on the axial line. It will be equal to 2kp multiplied by r divided by r square minus a square is r square. तो यहाँ आएगा बेटा r is power 4, then 1r will cancel, so electric field on the axial line is equal to 2kp divided by r cube. ठीक है ना बेटा? ये समझ में आया बेटा? So this implies again that electrostatic field with the dipole is proportional to 1 divided by r cube. That's it. Fine? Okay? So you write it down. Okay, so the next part is this, again important for the board exams. That's like this torque on a dipole in uniform electric field. Okay, so this is a dipole minus q plus q, and here this point is for example A, and this point is B. You can have that. This point is B. Okay, it's placed in the region of uniform electrostatic field. Okay, now the question is calculate the torque, calculate the expression for the torque on the dipole. Fine. Okay, so first of all, the dipole placed in the region of uniform electric field. Obviously, this minus q and plus q will experience the force. The force on this plus q will be in this direction, and how much is that? That will be equal to q multiplied by e. And the force on this minus q, that will be in this direction, in the backward direction, which is equal to q multiplied by e. The reason is that force experienced by a positive charge will be always in the direction of field, and force experienced by negative charge is opposite to the direction of field. So this QE and this is also equal to QE. Taken up? Okay. Then next what I will calculate is the torque. Now here I will write down the torque is equal to this QE and this QE being same in magnitude, opposite in direction, they will form a couple. And what they will tend to do is that they will tend to rotate the dipole and align it in the direction of the field. ठीक है ना बेटा? Then I will calculate torque. Now torque is equal to r perpendicular multiplied by m. R perpendicular multiplied by, what is this r perpendicular? R perpendicular is the perpendicular separation between the two forces. So here we have this and this, they form two forces. So this here r perpendicular. ठीक है ना बेटा? This is r perpendicular. Now if I use here, let me write down here sin theta. So sin theta is equal to perpendicular divided by hypotenuse, and perpendicular is what? R perpendicular divided by hypotenuse. क्या है बेटा? A plus A is twice A, which means that this R perpendicular is equal to 2A multiplied by sin theta. ठीक है ना बेटा? So this is the perpendicular distance. So this is equal to 2A sin theta. This is the perpendicular distance between the two forces. ठीक है ना बेटा? So that's what I will write like this. Torque is equal to R perpendicular के बदले लिखेंगे बेटा 2A multiplied by sin theta, और force जो है ना बेटा that's equal to Q multiplied by charge multiplied by electrostatic field. Now let me rearrange these terms. I will write them like this. First of all, I will write down Q, then I will write down twice A, then I will write down E, and then I will write down sin theta. ठीक है ना बेटा? Proper sequence. Fine. Then we know that the dipole moment is equal to charge multiplied by twice A. So here I will write down it is equal to P. This is the dipole moment. Charge multiplied by dipole length is dipole moment. Multiplied by electrostatic field multiplied by sin theta. Where theta is the angle between the dipole moment and electric field. You see that this is the direction of the electric field and this is the direction of the dipole moment. So the angle between them is theta. So that is equal to P E sin theta. ठीक है ना बेटा? So this is our equation number first. Let me write down the equation number first. Next I am going to write down in the vector form. यहाँ ध्यान रखो बेटा, in the vector form I will write down this. You know that this torque is a vector. It is an axial vector. This P with the dipole moment is a vector. Electric field is a vector. So I can write it like this. This torque vector is equal to P cross E. The reason is that I know that A cross B किसके बराबर होता है बेटा? AB sin theta. So the vector form is like this and its magnitude is given by this. That is called P multiplied by sin theta. All right. Now this is the way we calculate the torque. ठीक है ना बेटा? Next I will write down. I will discuss here the special cases. ठीक है बेटा? तो यहाँ मैं special cases discuss करने जा रहा हूँ बेटा. So here I will write down the special cases. Special cases. ठीक है बेटा? 3 different special cases I will discuss here. Okay. Number one special case is this. Number one special case is if theta is equal to 0 degree. Theta किसके बराबर है बेटा? 0 degree. That means the dipole is aligned in the direction of the field. In the direction of field. In that very case, torque will be obviously equal to Pe into sin 0 degree. Sin 0 किसके बराबर होता है बेटा? 0. Then this into 0 is equal to 0. So torque will be equal to 0. Fine. Number 2 is that if theta is equal to 180 degree. That means the dipole is placed anti-parallel of the electrostatic field. In that very case, torque किसके बराबर होगा बेटा? Pe multiplied by sin of 180. Sin 180 is again 0, so it's again 0. So the torque is again equal to 0. ठीक है ना बेटा? Then the special case number 3 here I am going to discuss. If theta is equal to 90 degree, that means it is perpendicular to the electrostatic field. In that very case, torque will be equal to Pe multiplied by sin 90. Sin 90 किसके बराबर होता है बेटा? 1. So torque will be equal to Pe, which is equal to torque x. So this is the torque. ठीक है ना बेटा? Okay, all right. So torque here, if theta is equal to 0 degree, torque 0. Theta equal to 180 degree, torque 0. Theta is equal to 90 degree, torque is equal to P multiplied by E, which is the maximum torque applied on the dipole. Fine. Next, what I will define is that the potential energy of the. Now I will define what next? Potential energy of dipole. So let me write down here. So आपको अच्छी तरह से ये समझ में आया होगा. Okay. Let me again repeat it. So it's like this. There are two forces on this dipole, QE and QE. They are applied at the two different points or along the different lines and are same in magnitude. Hence they form a couple. Now what they tend to do is that they tend to rotate the dipole and align it in the direction of the field. ठीक है ना? Like this. It's like this. Okay. So they tend to align it in the direction of the field. ठीक. Now this QE and this QE they form a couple. They form a. So the torque you want to calculate will be simply equal to perpendicular distance between the two. This is actually rigid body dynamics. Equation derived from rigid body dynamics. Or perpendicular multiplied by F. While in this R perpendicular simply the perpendicular distance between the two forces. तो ये एक force है बेटा QE, ये दूसरा force है this is the perpendicular that R perpendicular which is equal to twice the sin theta. I calculated here. ठीक है ना बेटा? Then substitute here twice is sin theta. Q multiplied by twice A multiplied by E into sin theta. This Q into twice is P, so P is sin theta, and the vector form is simply like this. Then these are the special cases we have discussed. Fine. Okay. All right. Now next is what? Next is the potential energy. Next is what? The potential. So let me write down here potential quickly. Okay. So next is this. Concentrate here. यहाँ ध्यान रखो बेटा. So that's what I will write down. Next is this. The potential energy of a dipole. Okay. So simply I will write down potential energy. Work done on a dipole. At least I will write down. Work done on a dipole in uniform electric field and potential energy of dipole and potential energy of dipole and potential energy of dipole. ठीक है ना बेटा? Okay. So the dipole is placed where? It's placed in a region of uniform electrostatic field. So this is the electrostatic field. Now to see that what this external electric field does is that it tends to rotate the dipole. ठीक है ना बेटा? And hence does the work on the dipole. So that's what I will write down is this. यहाँ ध्यान रखना बेटा. Okay. So what is actually? So here I am going to start with this. Torque on dipole. We have already calculated that. And what's that? Torque on dipole is that's equal to torque which is equal to P into E sin theta. ठीक है ना बेटा? Clear? All right. Now you see that this torque which is called P sin theta is a function of theta. It's a function of theta. That its value depends on the theta. As theta changes, the torque also changes. Now how to calculate work? How to calculate? I will write like this. Infinitesimal work done. Infinitesimal work done work done on dipole. What does that mean? Suppose that the dipole is slightly displaced by a small angle of d theta. Okay, then work done will be given by this. Tau, this is given by this, sorry, work done dw. In next one, work done is equal to tau multiplied by d theta. Okay, torque multiplied by the angular displacement. So we get here dw will be equal to tau के बदले क्या लिखेंगे बेटा? Pe multiplied by sin theta into d theta. All right. Okay, so it's like this. Then this in turn implies that we want to calculate the net work done W, then we got integration of dW, which is equal to PE into integration of sin theta with respect to theta. Fine. And the limits of integration theta 1, theta 2. Okay, where theta 1 is the initial angle of the dipole with respect to horizontal, and theta 2 is the final angle with respect to electrostatic field. Fine. Now W is equal to, here I will write down P multiplied by E. What is the integration of sin theta? That's minus cos theta. Difference of sin theta is cos, so integration is minus cos theta. Limits of integration from theta 1 to theta 2. Okay. Now upper limit minus lower limit. So here I will write down W is equal to this minus PE here. Then upper limit is cos theta 2 minus lower limit is cos theta 1. So this is the work done. So this is the work done. This is the equation for the work done. Right? Taken over. Now next I will define the potential energy. In order to define potential energy for any value of theta, I'll define here a reference level. I'll say like this. If initial angle, if theta 1 is equal to 90 degree and theta 2 is equal to theta, that means if the dipole is initially perpendicular like this, if it is initially perpendicular to the electrostatic field and then it's rotated by some angle theta, then in that very case, what will be this work done? It will be equal to minus PE multiplied by cos theta 2 is cos theta, isn't it? Cos theta 1 is minus cos 90 degree, and then you know that cos 90 is 0. किसके बराबर है बेटा? 0 के बराबर. So work done will be equal to minus PE into cos theta, or it is simply equal to minus P dot E. ठीक है ना बेटा? And then this work done is stored as the potential energy of the dipole. It is done to the external agents. It is stored as potential energy of the dipole. So this implies that the potential energy is equal to work done, which is equal to minus P dot E. So this is the expression for the potential energy of the dipole, which is equal to minus P dot E. ठीक है ना बेटा? Again, you see that torque on the dipole is equal to P is sin theta, which is a function of theta. Now, how to calculate work done? First of all, calculate the work done, infinitesimal work done for the small displacement d theta. That's like this. So torque के बाद मैंने क्या लिखा बेटा? P is sin theta d theta. Now net work done you want to calculate, integrate this function. So P is a constant. It will be out of the integral. Integration of sin theta is minus cos theta 1 to theta 2. So minus PE here, then upper limit minus lower limit cos theta 2 minus cos theta 1. Then here if theta 1 is called 90 and this is called reference point. When theta is called 90 degree, obviously the potential is called 0. So this is called reference point, with respect to which we define the potential energy. Theta 2 is called theta. So work done is called to minus PE multiplied by cos theta minus 0. Cos 90 is 0. So ये आएगा. So then you know that 8P is cos theta is equal to A dot B. So this is minus P dot E. Then this. Then here let me write down the special cases here. यहाँ मैं बेटा special cases लिखूँगा. Okay, so let me write down the special cases. Number 1 is that theta is equal to 0 degree. Theta is equal to 0 degree. In that case, U will be equal to minus PE because cos 0 is equal to 1. Number 2, theta is equal to 180 degree. Cos 180 होगा बेटा minus 1. So potential energy will be equal to plus PE. And number 3, if theta is equal to 90 degree, cos 90 is 0. So potential energy will be equal to 0. Okay. So hence we are done with today's lecture. And our today's lecture was electrostatic field due to dipole and potential energy of the dipole in the electrostatic field. Very important question for the board exams. So what we'll do is that we will make a note of it and then make sure, and then you can expect this question the board exams. ठीक है ना बेटा? Number 1. Number 2 is that tomorrow's lecture will be on the Gauss's law and the application, 3 different applications of Gauss's law, which is really important for the board exams. So you take care of yourselves.